Okay, next section we're going to be looking at determining compound formulas. The goals are to express the composition of a compound in terms of percent composition and to determine the empirical and molecular formula of a compound using percent composition and other experimental data. So let's look at percent composition. This refers to mass percent composition, or more simply, mass percent. For calculating mass percent of an element, you use this formula here. The mass percent of an element in a compound is the mass of the element in the substance divided by the mass of the substance itself. All of this times 100%. Now, when we talk about the mass of the element versus the mass of the substance, you can use the mass in AMU and the mass in AMU, or the mass in grams and the mass in grams. Or you can actually do this based on experimental data. You can experimentally determine the mass of an element in the substance and the mass of the substance when it becomes a compound. I should say, the mass of the element when it's reacted with something to become the substance. So let's take a look at these ways of figuring out formulas of a compound. So let's look at mass percent from atomic weights or molar masses. So in this case, we know the formula of the compound. So here we want to calculate the mass percent carbon and the mass percent oxygen in copper 1 oxide. So to calculate the mass percent copper, we can do the atomic weight of 2 coppers, because there's 2 coppers in the formula, divided by the atomic weight of 2 coppers and the atomic weight of 1 oxygen, because there are 2 coppers, 1 oxygen in the substance, times 100%. So here, the mass of 1 copper is 63.55 AMU, and there's 2 of them, so we get a total of about 127. Here in the denominator, we get that same amount here, but plus the 1 oxygen atom, so we get a mass of about 143. Divided by 100%, or times 100%, not divided by, times 100%, and you get 88.82%, okay? Now, the mass percent oxygen we can find 2 ways. One is to take the mass of the oxygen divided by the mass of the substance times 100%, and here we get 11.18%, or we can simply say, well, the mass of oxygen should be 100% minus the mass percent copper. And here we also get 11.18%. So how do we get mass percents from an experiment? So here's an experiment. Copper is reacted with oxygen to form a compound. The mass of the final and pure product is 2.41 grams. The mass of copper used was 2.14 grams. You can see in a case like this, since oxygen's a gas, it would be very difficult to weigh. Okay, so how do we calculate the mass percent copper in this compound of 2.41 grams when we started with 2.414 grams of pure copper? Well, we use the same formula. So here, first I'm going to calculate the mass of oxygen in the product. And to do that, we simply take the mass of the product, subtract the mass of copper, and we get 0.27 grams of oxygen. We'll need that later. Okay, so let's take a look at calculating the mass percent copper in the product. So that's going to be the mass of the copper divided by the mass of the product times 100%, and we get 88.80%. You can see that this is the same number that I had previously because this compound happens to be Cu2O, or copper 1 oxide. So in general, again, calculating the mass percent of an element in a product is the mass of the part, the mass of the element in the product, divided by the mass of the whole, the mass of the product itself. In general, percent means part over whole times 100%. Now here, I've left this for you to do to calculate the mass percent oxygen in the product. How would this differ from the previous problem where we did this for copper? Well, instead of 2.14 grams of copper, we know there's 0.27 grams of oxygen in the product. So let's take a look at a problem from the book. Using percent composition, what is the mass percent of each element in propane? What mass of carbon is contained in 454 grams of propane? So propane has the formula C3H8. And I'm going to go ahead and use atomic weights here. So to get the mass percent carbon, that's going to be the mass of 3 carbons, that's the part, divided by the mass of 3 carbons plus the mass of 8 hydrogens. Now, we could have written it this way. We could have put that down as 3 times the mass of 1 carbon over 3 times the mass of 1 carbon plus 8 times the mass of 1 hydrogen. And of course, all of this is times 100%. Okay, so let's throw in some numbers here. So here, for the mass of 3 carbons, we have 3 times 12.01 AMU. And below, we have the same thing. But in addition, in the denominator below, we have the mass of 8 hydrogens. So that's going to be 8 times 1.008 AMU. You'll notice I am keeping my units in the problem. And if you don't keep your units in the solution here, you will be deducted points on an exam. Okay, so let's figure out what this is, and we need to multiply this by 100%. We can do an ish here. 3 times 12 is 36. 36 plus 8 is 44. 36 over 44 is going to be roughly, let's see, 36 over 44 should be roughly 80%. Okay, so let's see what we get. 3 times 12.01 is 36.03 divided by, and I'm going to put parentheses here, 3 times 12.01, 01, plus 8 times 1.008, and I'm going to put my end parentheses, and I get 0.81, but now I need to multiply by 100. Okay, so we're going to get 81.71%. So the mass percent, and I should have written carbon here, is 81.71%. Now, what's the easiest way to get the mass percent hydrogen? Well, the easiest way is this. The mass percent hydrogen is equal to the mass of the compound minus the mass percent carbon. So this is going to be 100% because the compound is the whole, minus 81.71%. So we're going to get what? 18.29%, I believe. So I'm going to take my 81.71, subtract 100 from it. Now this comes out as negative 0.288, which rounds to 18.29. Of course, the answer is positive. Okay, now the next question is, what mass of carbon is contained in 454 grams of carbon? So I want to take propane. So I want to take my 454 grams of C3H8 and I want to turn it into grams of carbon. So how do I do this? Well, the answer is in what this percentage means. This percentage means 81.71 grams of carbon out of 100 grams of C3H8, propane. Whenever you have a percentage, by definition, it means over 100. Don't move the decimal over 2 places. That's foolish. Put it over 100 because that's the definition. Plus, I have these labels here, which are really nice. If I just move the decimal over 2 places, what are the labels? Who knows? So now I can do this problem very easily. 454 grams of C3H8 times, and you can see this is set up the way I want it with the C3H8 on the bottom. And what's really nice about this is that the unit and the label cancel, and I will have grams of carbon automatically in my answer. I don't have to say, oh, and by the way, it should be grams of carbon. It is grams of carbon. So when we do this work, 81% of 454 is roughly 350, a little more. So I'm going to clear this. 454 times 81.71 divided by 100, and we get 370.9, which rounds to what? 371 grams of carbon. 3 significant figures because of that. All right. We're going to cut this lecture short, and next we're going to be looking at empirical formula and molecular formula. And let me take a look real quick here. Yeah, if we continue, this is going to be a really long lecture. So what we're going to do is make that one just a short lecture, and this one will be a little bit longer, but it'll be easier for you to digest. All right, thanks for listening.